professional staff involved. So there's myself and Aaron, and then there's Dr. Sandie Dann, Dr. Firat Batmaz, etc., etc. But we've got, so there's Sandie's from chemistry, Firat's from computer science, Mike Walsh is from physics, Helen Willcock is from materials, Sarah and Sweater are both from biology. So we've got a real mixture of STEM subjects in this project, which has really made it what it is, as you'll see as we go along. So I think it's quite important to note that difference in the different disciplines, and we've also got 2 student developers as well working for us at the moment. Myself and Aaron work in the School of Science Enhanced Learning team at Loughborough University, and this is a specific a team working on specific enhanced learning projects or e-learning projects for the School of Science, so very science focused. A bit of background about where we are with this. This presentation is sort of about the journey of where we've got to. We have done a small feedback. I don't really want to use the word study, but we have collected student feedback that we will talk about at the end, but it's not as rigorous as we would like to do at the end of the project next year. So this is more about like how we've got there and where we're at so far. So it started with, it's both been Teaching Innovation Awards at Loughborough. So we get a little bit of money. I think we managed to get up to, I think it was just about $5,000 in the first year, and we've only got about $2,000 this year, but then also got the student developer on top of that. So we're not talking about a lot of money here. And the first one was just somebody sparking an idea in chemistry that they would like to use virtual reality in chemistry. And it was very much based on an experiment pre-lab, before they go into the laboratory, do an experiment, see some theory, play with some atoms, and then go and do the experiment in real life, and to see how that worked and did it improve their learning, etc. That went well, as you'll see by the student feedback. So this year, this current project, we put in again, and we got some more money to take it to the next level and move it across the different subjects and try it out a lot further. It was also sparked this year a lot more by the fact that we've got a new STEM lab building at Loughborough. They've spent lots of money on it. It's where all these new fab labs are for science and engineering to all work together, and even design school in the labs. So we've got this great space, and now we need to take it to the next level and see what else we can do with it. Rather than doing the same old stuff that we've always done, we've now got some really great space and technologies to use. So it started with computer science and chemistry, wanting to have a go, and then it's moved into chemistry, biology, materials and physics. So the aims of the first project both really have similar aims, but it was a lot about the deep learning and the idea of taking their learning out of the lab and being able to practice and go over things a lot more to try and understand it a bit better. And we wanted to give them more time to explore the experiment and the instruments. Then when they're in quite a pressured environment in the lab and they've got everybody around them, it's a bit more difficult. We were also, in the first project specifically, we used 360 images to try and get familiarisation. They were going into a new building, so we wanted to use 360 images of the new building for them to get used to it. And we've actually moved away from 360 images this time, and we're all in the virtual lab. So you'll see that in the demo shortly. But the main aims of this second project is to be really Loughborough specific. Although we've moved away from the 360 images, we've modelled the instruments exactly as they are in the lab. There's lots of different manufacturers of different instruments for all the different subjects. So the students reported that they wanted it to be Loughborough specific and the stuff that they're really using in the lab. So that's what we've done. And it's all about, as I said before, we've got this new lab. Let's increase the use of learning and technology, and really the other side of it is health and safety. The stuff you can do in the virtual world with the health and safety that you can't do in the real world. So to try and teach them how to do that and make it a bit more exciting than the usual health and safety lecture at the start of the term. So our deliverables were to get an evaluated approach to this different lab teaching that we were proposing, and to see if it could be applied to other areas, and to create this VR application using the 4 different STEM subjects, so 4 different experiments in this application. Transferability of the application to Igloo Vision, which I'm just going to show you. Aaron's going to mention it a little bit afterwards, but we have this at Loughborough, which we've paid a lot of money for, and I personally don't know how well we're using it at the moment. It looks like this, scaffolding. It's like a 360 projection thing. It looks really fancy, but at the moment we're only using it for one module. and we spent a lot of money for the software to do that. Now that we've used Unity to do what we're doing, we really believe that we could be developing all sorts of different things for this bit of kit. So that's part of it. And part of that is to do a study to compare the learning in the VR. You've got your headsets on, and it's very individual. If you go into that igloo where it's all around you, and you can get 3 to 4, well, I think it's actually five people you can probably get in there, 5 to 6, with it being still comfortable. What's that group learning like in that sort of 360 space in comparison to the individual learning on the headsets? So we are going to be doing a study to compare that at the end of the project as well. And some comprehensive student feedback on the tool. Obviously, we want as much feedback as possible on this. Just to simplify it, this is about a virtual reality application students can access before or after a laboratory session to enhance the experience. And to practice and go over things, act as a resource when they're writing up their results. And something I've noticed from being here today is that a lot of what we've talked about is VR in the classroom, and I've sort of realised that we're getting them to do it outside of the classroom before they come, almost like flipped learning, and that could actually bring a lot of issues, seeing as they're going to have to download the app on their phone, they're going to be using it on their own, they're going to be basically coming and borrowing the headsets. We've got 30 headsets, so I think that's going to cause us something interesting. Anyway, we'll see how that goes. So why VR? We went with it because of, obviously, real labs, the health and safety restrictions I mentioned before. It's time limited, and the chemistry academic involved, the one that started this all off, really felt that they were just sort of recipe learning. They were just reading the lab script, doing what it said in the lab script, and not really understanding what was going on and thinking about how they got the results. Obviously, virtual reality gives us this sort of gamification thing we've heard a lot about today, and enhances the experience, and it does just connect the theory and the practical together. Just a quick note to say that we did originally back a couple of years ago now, start with a trial from a company called Labster, which was really good, and the students liked it, but the real thing and the reason why we went off and did our own thing is because they wanted this Loughborough specific thing. They wanted to see the experiment that they were going to do the next day, which obviously with a package isn't always possible. So the process of how we got here, I want to leave time for Aaron to do a little demo, because our group, because it's obviously a lot more widespread at Swansea, but for us in Loughborough, we're the first people in the university to do this. It's very new to us, so our academics, they said, you've got to tell them about how we got here, how we did it, in case anybody else wants to know. So it's quite difficult to choose, first of all, what to put in the virtual reality. We found in chemistry that we chose an experiment that, on reflection, you could just do that in a 2D computer simulation. You could click the buttons and you could do the same thing. They did have atoms that you could sort of move around that was quite interesting, but we thought for this round and this project we needed to make it more about what you can't do in real life. So what you'll see Aaran demonstrate in a minute is the physics experiment where you actually go into an instrument. You can't do that in real life, and that's where you have to find the distinctions with virtual reality, in which we've really learned. How are you going to make it, who's going to do it, and how do you translate the academic into the technical, which we hope we've helped to do. So for us it starts with some form of project manager that can hold all of these bits together, the academic, the technical, and pull it all together really. For us that was me in my role, because I was in the professional services side of things. It's easier, it's a lot harder when you're in the academic side to do all of these at the same time as teaching and research and everything else, so we're quite lucky in that sense. I think group meetings were the best way to start. We threw a lot of ideas onto the table and all the different disciplines got to share things together. Then we moved on to individual meetings, and it took a lot of time to work through with the academics exactly what we could do with this. Again, they were throwing out these sorts of 2D ideas, and you have to really delve into, no, but what can't you see? Like, let's do something really different here. Because I think if you haven't used VR before as well, we did show them a lot of VR, it's very difficult to see that. Then we moved to storyboarding through the different scenes to show that not only the technical, the developer, how the academic wanted it, but so the academic can understand how they wanted it. We then recruited the student developers, which is very important here. We use student developers mainly because they're obviously interested, probably a bit cheaper, but it's been a fantastic thing working with the students. It really has been made by students for students, and that's something that at Loughborough we do a lot of and we're very, very proud of. Development, so then we're just coming to the end of the 10 weeks development. So in advance, the app that you're going to see isn't completely finished. There's spelling errors and it's definitely a beta version. But we're near the end of the student development section, and Aaron's going to be tidying things up after that. Testing is obviously very important. You're so close to it that you don't see it. You don't see what's wrong with it until somebody else tests it. An evaluation, which we've not got to yet with this app, but that's obviously going to change everything, and then we will need to disseminate it. So Aaron's just going to...
Do you just want to go through this bit quick? And then I'll...
Yeah, you set that up. Okay, so just the techie bits. Is that we went for mobile because obviously we're asking people to do this pre-lab. That means that we need it to be accessible to as many people as possible. We therefore need it to be on Android and iOS. iOS causes more problems because it's not as easy to get things on the App Store, but we're trying. We have already compiled it for Android. We're yet to compile it for iOS, but that's coming in the next week or so. We went for mobile because it was scalable and affordable, although our student developers get very frustrated because mobile isn't the best. The frame rate's not brilliant. It just it's a lot harder to deal with. We use Unity to make it. And the student developers didn't have any experience of Unity before they started. I put into the timescale 2 weeks for the student developers to learn Unity, and they did it in a day. So they knew exactly what they were doing. So I should say the student developers, one was a computer scientist and one is a systems engineer. So they definitely picked it up very quickly, and they've been brilliant. And the technology used, so I mentioned the Igloo before, this sort of 360 projection. We've also got HTC Vive and some Oculus Go's. It's been compiled for the Oculus Go and it works fine. HTC Vive, we haven't tried it on yet, but for this project, we're more bothered about the mobile so that it's scalable. Is that okay?
Yeah, okay.
So Aaron's just going to show you... Oh, upside down?
No, it should automatically flip the right way up.
Oh, we're upside down on here.
Huh.
Turn the phone around. Oh, is that because the visualiser's upside down? So we've had to have a hack and use the visualiser.
Yeah, the HDMI is unfortunately not working with our Miracast. So we're routing it through the visualiser, but you're right, the visualiser is going to flip it upside down. It's the right way up for me, so...
Oh, wait. It's back. Is it back?
No, it's
oh, it's because you're... Okay, maybe turn the headset around.
It's
well, that... Yeah, but you won't be able to see anything.
I'll try my best.
Or look on the screen, Aaron, if it's easy. We'll look just...
I will try my best to do it this way.
Why do you look at the screen?
Yeah, and then click. Yeah. Use the screen and click. This screen.
Okay.
Or this screen. Go on that one.
I'll use the screen and click.
Okay. I was going to talk through, but now we can both do it.
It's okay, go for it.
As any demo goes, yeah, it always goes wrong. So this is the room that people land in. In the original app, it was all these 360 images. Now we've used a sort of model that you can get off Unity. Actually, we bought it. And then we played around with it to try and make it look similar to the STEM lab. We've got these things in here about, this is to do with motion sickness. So the student developers did a bit of research into it and found that if you adjust your height so that it's your height, or makes you feel like you're in the right place, then that should help motion sickness. And also you can change whether you do the teleportation or you use a controller to move around, because that can help. Here we won't go into it now, but there's a familiarisation room. So this is space to get to know VR if you've never used VR before, try out the tools and get an idea of it. And we found in user testing, obviously. I haven't used it before, it's quite disorientating. And then we'll just go into physics. I have to move through quickly because we'll run out of time.
Okay.
So this is just a menu we hope to add to later on if more people obviously create experiments. So we start off with instructions and then we move through. So this is a sort of prep area where they have to do things like, and this is a little bit of health and safety bit for physics anyway. They need to recognise what things are and label them. There's some gloves there. We've put a highlighter on there because we found in testing that people didn't really know where to go and where to click. So here they have to get the lab script out and the drawer should sort of highlight and they get the lab script. The lockers, we've modelled on the lockers that we have in STEM Lab. Again, try and bring some familiarisation in there. And the academics find it very annoying that they still think that water is not a drink and they still think they can take water into the labs. So that's been put in there. We move into the lab. Also, the frame rate drops because we're mirror casting, so it's not as bad as it looks on the screen. And here we have this sort of experiment area. Again, we've put arrows in because people get lost, apparently. So we'll see what the students say. So here, Aaron's levelling the machine. It's a bit more of a fun game way of saying that we have to level. I'm going to have to really quicken up, Aaron.
Okay.
And here, this instrument, Aaron modelled on SketchUp, I think.
Yep.
And this is the exact instrument that they have in the lab. So we'd level it. They're doing the controls here that are on there, but on the side, so they can really see what they're doing. And they have to put the pin in. Basically, we had a go at this experiment to obviously understand what we were doing in the VR. And when you look in the here in the microscope, obviously everything is so tiny, and apparently it's really frustrating when you're turning the knob. This is the Millikan experiment for any physicists. It's really frustrating because when you're trying to get a drop to measure, they just fly off. So in the virtual reality, you can slow down time, you can slow down gravity, you can do all of these things that mean that the student understands it a lot better. We haven't got the thermometer in there yet, so Aaron's remembered what to put in there. Hopefully, 100,000. Okay. So then you have to spray some oil into the thing. I could do this experiment now, I reckon. Okay, so this is the bit that we're really quite proud of. I think I'm proud of all of it. But for physics, so we're in the instrument now. So as I was saying, when I looked on that little oil drop thing, it was all blurry and it was really difficult to see what you were doing. Here, Aaron, if you just turn around a bit, I don't know if they're dropping yet, but there are oil drops dropping all around you. So you are literally in the instrument. You can select any of them, and they then pop onto the little measurement scale there, and then they are timed dropping down that scale. And then the time, because I don't think we're going to have enough time to show you, but in the time then goes back into the room, and you record it on like a spreadsheet thing, and it goes into the formula. It's all right, Aaron, you can come out from being upside down. So here's just a few screenshots of the other rooms that we've done so far. So there's chemistry. Chemistry is the one with the little flasks, and then materials is a big. We're doing in materials. They're crushing a bit of metal. I should know all the details by now. I'm sorry. They're crushing it, so we've got a big hammer thing that swings. The what? Impact tester. Impact tester to all you materials people. And it's about fingers getting stuck in there, so there's health and safety there. And biology is going inside of a cell. Okay, so really quickly, this was from when we first did this with the chemistry. So these results were from have to say, the first application was nowhere near as good as this. The level of student developers' skills and experience is very different, and we're so chuffed at the student developers we've got this year, because obviously the first one was great, but this has gone that next bit further. So I'm not completely happy with the results of this study because I don't think our questions were the best, but we had a pre-questionnaire, they did the application, then we did a post-questionnaire. We involved questions about VR, about how well they understood the experiment, and also chemistry questions to see if they actually recorded if they actually knew the answers a second time. So you can see there that all the 20 participants felt that they understood the experiment, they had increased confidence, and they felt that it could improve their learning. Again, I don't really like those words. So that will be changed in the next one. And my big thing is that 80% of the participants, it was only 20, but 80% of the participants say that they would like to see it used in their modules. So to me, that was enough that we needed to go forward for the next project. They felt that they could practice the experiments before they were doing them, all of the things that we were looking for. Lessons learned, I mentioned some already. Use VR to its best. Get really good quality student developers if you can. And if you have the chance to get more than one student developer, I would also really recommend that, because they've learned from each other and they've really helped each other, and it's been a really nice process to watch. And as I said before, they want to do something specific. Motion sickness we found in the first lot of testing, because the frame rate and because the application wasn't as good as it is this year. I'm hoping that the motion sickness will be better this time round. Get senior management on board quickly. Obviously, we were just a little we're just doing it on our own, so you had to get senior management on to get into the igloo, for example. don't assume users' technical ability, because we've already found it's not the same everywhere. And test. What's next? We're going to be using it on the biology module, the physics module, so 100 plus students are going to be using the application. So we're going to have a lot of data to collect and analyse. And as I said before, we'll do that study to compare individual and group learning. And we want to create like an interest group, at least in the university, to get some more people involved, because as soon as we started mentioning it outside of our school, people are interested. And we really want to obviously publish and disseminate as much as possible. And we have got another project with health and safety. They've bought us loads of kit, and we're going to develop some health and safety training as well for the university. Thank you.
Right, so we've got some few minutes for questions. There's nothing on Sunsort at the moment, so just struck me then there's lots of pioneers going on, isn't there, in lots of different institutions at the moment, so that's fantastic. And I'll be following up on this one because I'm doing some lab stuff not in VR, so I need to have a chat with you.
Yeah.
Have we got any questions from the audience?
Yeah.
Was there anything in place for a digital pre-lab or that type of thing before?
I think some modules perhaps might have like a quiz on Moodle. No. They've started now to move into videos, so there's going to be a few videos this year, but not really. They hadn't really gone that way.
How long did it take to create?
Yeah, I didn't mention that. Yeah, so that application we haven't completely finished materials and completely finished chemistry, but so physics and biology completely finished. That's taken 10 weeks of the student developers' time, but that's 2 people working for 10 weeks. So
that's 2 people for the 2 courses or for the 1?
For the 2 courses, so yeah, so I guess 5 weeks each.
Is that like sort of 8 hours?
Yeah, I made them work a full week. So yeah, they're on summer studentships, and they heard that some of the summer studentships were just at home writing a paper, and I was like, no, you're getting in and you're developing. So yeah.
Okay, and any what?
Are you looking to integrate any evaluation for the students while they're doing the experiments?
Why they're doing it?
No.
Yeah, in the sense that at the end you have some sort of results,
Yeah.
whether you did well or not, and what kind of metrics are you looking to manage?
Yeah, so to evaluate the virtual reality, or for them to like find out if they got the right answer.
I think it's to evaluate the students themselves.
So to find out the right answer. So the question is for the students to find out if they got the right answer in the experiment. I forgot to repeat the last question. So as they go through, they get told that they're correct, and they can't really go to the next step until they've got it correct. And then right at the end they get like the big thing that says you've put in all of the right answers, you're correct. In biology, they're labelling the organelles in a cell, and they can't move to the next room until it's all correct. So that idea that they can't get to the next level, we found that in student feedback actually. The fact they can't get to the next level was they liked that. They wanted it in levels.
Okay, just before that one, I've got a question from Caitlin on Sunsart.
Okay.
So again, can you repeat it? Have you seen other universities use VR in this way?
Have we seen other universities use VR in this way? Well, I've seen through Labster, through the commercial package, that other universities are using it in this way. I can't remember the names of the universities off the top of my head, but yeah, I suppose when we saw that as well, that other universities were thinking about it, that's another reason why we went down the line. But yeah, I think they are, yeah.
Okay, great. Sorry, this lady behind you.
I was just wondering, how many experiments are included in virtual reality?
How many experiments are included? So at the moment, there's 4 experiments included.
I want to ask you a question about, I know you mentioned Labster and how other universities, I know Westminster spent 50,000 to be able to give their 2,000 students access to Labster.
Okay, yeah.
But they only actually used 12 experiments, so it's a lot of money for 12 experiments.
Yeah.
How much are you guys spending on student developers?
Developers, yeah. So in total, so if you add up the projects themselves, or just the student developers, because I suppose we've bought kit.
Yeah, let's not count hardware because it can be reused for other stuff.
Okay, so the student developers, it's about £2,000 for two it's around about like £2,000. They get paid about £1,000 a month.
Yeah.
So, and we've had so far, it takes a student developer 2 months. So, what's the maths? Yeah.
Is it 4,000?
So 4,000 per experiment. Yeah.
Okay.
I know you said that you're going to have plans to disseminate it. Is that to the UK higher education
Yeah.
community, and is that going to be for free and Creative Commons so people can take Unity code and
Yeah.
go with it if they need to?
Yeah, so the question is if we're going to disseminate to the sector and if it's going to be open source. Yes, the plans are to disseminate as far and wide as possible, and we want to write it up and publish it. Will it be free and open source? I don't know the answer because we've not got that far, but my gut answer is that yes, it will be open source because we're very much about that. The other thing that I didn't mention about the whole how much we spent on student developers is the computer science academic involved, Firat, would really like to develop an authoring tool for this so that it doesn't take student developers to have to make this, that we've got like a tool that academics can say, this is my experiment, I want this instrument, and then to do this, and then it's all created for them. It's a big task, but that's what he's got in his mind, and he usually gets what he wants. So if we did create something like that, it would be brilliant for everybody. So, yeah.
Okay, so can you ask any more questions for Samantha and Aaran after the session? But, there's another round.